Today we visit the production plants of Axens Aromatics in Plavnica in Slovakia. Peter van der Schaft, the managing director, will give us some insights into the production of nonadienal.
Axens Aromatic was founded in 1986 and is a privately held company. Axens is developing, manufacturing and selling natural aroma ingredients to the global flavor and fragrance industry. The flavor and fragrance industry is using these ingredients to make natural flavorings for addition to foods and beverages. Axens has its head office in Germany and its R&D and production facilities in the Slovak Republic. Trans-2-cis-6-nonadienal is an important constituent of melon, cucumber and many fruit flavorings. Axens is manufacturing the natural version of this molecule in its factory in eastern Slovakia. According to European flavor legislation, a natural flavoring can be prepared by starting from a natural substrate and applying physical, enzymatic and microbiological processes. So this legislation provides quite a challenge for applying industrial biotechnology. In our process for the manufacturing of natural 2,6-nonadienal, we use hydrolyzed linseed oil, which is rich in linolenic acid as natural starting material. In addition, we use small cucumbers or gherkins as an enzyme source. Gherkins contain both lipoxygenase and hydroperoxide lyase activity. Lipoxygenase is able to convert linolenic acid into its 9-hydroperoxy derivative. This hydroperoxy fatty acid is cleaved by the cucumber lyase into trans-2-cis-6-nonadienal and an omega-oxo-C9 fatty acid. So we have to bring together the hydrolyzed linseed oil and the enzymes, and that is what we do in this big homogenizer. We load this with gherkins, water and some hydrolyzed linseed oil, and then we start to homogenize and make a kind of cucumber smoothie. As soon as the gherkins are crushed, their enzymes come into contact with the linolenic acid present in the hydrolyzed linseed oil, and instantly 2,6-nonadienal is generated. The gherkins need to be fresh and intact before processing because their enzyme activity decreases rapidly upon aging and crushing. During the cucumber season, our factory operates 24 hours, 7 days a week to process 50 tons of gherkins per day. One could think about isolating and immobilizing the cucumber enzymes, but especially the lyase is not easy to handle because it is a membrane-bound enzyme which loses its activity very fast. After the enzymatic reaction, our cucumber smoothie contains around 5 milligrams 2,6-nonadienal per kilogram. Of course, this is a very low concentration, but we have developed a very efficient method for the isolation and purification of this compound. The first step is solvent extraction of the smoothie to isolate the volatile fraction, including the 2,6-nonadienal. So a natural organic solvent is added to the cucumber smoothie and mixed with it. The next step is phase separation, which we conduct in a continuous way. The watery remnants of the smoothie are delivered to a biogas station for energy generation. The extract, the organic phase, is concentrated by distillation in a continuous evaporator, and further isolation and purification is conducted by fractional distillation, and the organic solvent is recovered and used for a next extraction. As you can imagine, the price of this material is very high, and much more than 10 times the price of gold. 1 kilogram nonadienal is generated in 200 tons of cucumber smoothie containing 100 tons of gherkins. And of course, there are also losses during the isolation and purification procedures. However, the odor threshold value is so low that you only need a very low dosage in foods and beverages to have a very good flavor performance. So the cost in use in food is quite acceptable. According to the same biochemical principle and using the same equipment, we are processing other crops to manufacture other natural flavor chemicals. We are processing plantain to produce trans-2-hexanal from linolenic acid from hydrolyzed linseed oil. The lipoxygenase in plantain specifically produces the 13-hydroperoxide from linolenic acid, which is converted by its hydroperoxide lyase into cis-3-hexanal, which is converted by an inherent plantain isomerase into trans-2-hexanal. This molecule is important for apple and other fruit flavors. We are also processing mushrooms to produce 1-octene-thiol. In this case, the mushroom lipoxygenase generates the 10-hydroperoxide of linoleic acid, which is present in hydrolyzed safflower oil. The mushroom hydroperoxide lyase will convert it to 1-octene-thiol, which is used in natural mushroom flavors. And we also process potatoes. Potato lipoxygenase will generate the 9-hydroperoxide from linoleic acid, which can be converted by the potato lyase into trans-2-cis-4-decadienal. This compound is an important constituent of natural roast chicken flavor. In general, these bioconversions result in much higher concentrations and yields of product compared to the cucumber process, and therefore these products are also much cheaper than the 2,6-nonadienal. So Axence has developed an efficient technology to produce natural flavor ingredients using plant enzymes.